Hello everyone, in this video we are going to see about the algorithm DDA algorithm, which is the line drawing algorithm. Let us see first of all what is the DDA algorithm. DDA stands for Digital Differential Analyzer. It's a scan conversion line algorithm. The Cartesian slope-intercept equation of the straight line is y is equal to mx plus c. We all have learned in mathematics, where m is the slope of the line and b is the intercept. Given the two endpoints of a segment which are specified by the positions x1, y1 and x2, y2, let us see how to draw the line. So line will be shown in the figure like this, and also let us find out how to calculate the x and the y and y value, y intercept of b as well as the slope m. Okay, so this is the diagram that shows the line drawing. There's a line x1, x2, y1, y2. The line starts from x1, y1, the starting point, and this is x2, y2, the ending point. And the algorithm is going to find out these points to draw in between the starting point x1, y1 and x2, y2 ending point. So the calculations are like this. M is equal to y2 minus y1 divided by x2 minus x1. This is a mathematical formula. We all must be familiar. And b is equal to y1 minus m dot x1, m into x1. So with this calculation, we will be able to find out the slope m and the intercept b. So this is the calculation. So let us see the steps, how the algorithm goes. So the digital differential analyzer algorithm commonly is used to computer graphics to generate a line segment between the two specified endpoints. So here how it works. Point 1, input. Begin with the two endpoints of the line segment denoted as x1, y1 and x2, y2. Second step is find the differences between x2, x1 to find out dx, and y2, minus y1, the difference of y, which is dy. So this differences will help to step into the till the end point of the line. And the third point is slope calculation. Determine the slope of the line as m is equal to dy by dx. Sometimes the slope may be negative or positive, which means the line may go up or the line may go down. So next step, the fourth step is we are supposed to calculate set the initial point. Set the initial point of the line as x1, y1, and then we have to loop through the x coordinates. So how to loop? We have the calculation here. Increment the x coordinate by 1 each time. And after incrementing, we are supposed to calculate the corresponding y coordinate using the equation y is equal to y1 plus m into x, x minus x1. So with this, we will be able to find out the y coordinate for the corresponding x coordinate. And then we plot the point which is we have got from x, y. And these steps is repeated till we reach the end of the line x2, y2. So these are all the steps to follow the line drawing algorithm of digital differential analyzer. It is very fast, it is easy to implement, and it is also suitable for real-time applications. Let us see the advantages and disadvantages of the algorithm. Advantages are it is a simple and easy to implement algorithm. And the second advantage is it avoids multiple operations. It have only the addition and the operation, and they don't have much high complexities. And it is faster than the direct use of the line equation because it does not use any floating point multiplication, and it calculates the points on the line. So while we calculate the line, it is only on the line. That means we are going to step from starting point to ending point with the points calculated in the direction of the slope. The disadvantages of this algorithm are it deals with the rounding of operation, because we know that we have the round of operation to get the value of x, y. We have an algorithm, we have a function to round off. So that will create some error in the computation. And there are some floating point calculation which is giving the high complexity. The second disadvantage is as it is orientation dependent, it has poor end point accuracy. What does it mean is we are just moving from the starting point to the ending point with the steps of dy and dx calculated by with the m and b. There it can happen sometimes because of the rounding off. We may not end with the correct end point. We may go little one or two steps away or towards the end point. That's the disadvantage. It means the line will not end in the correct end point. And then due to limited precision of the floating point representation, it produces as a cumulative error. So as we are adding these cumulative values again and again, this error is cumulative, means it is added up for every pixel. So it will give some uh, relative error, which is very markable. So that's all the steps. This is how the line is drawn using the C implementation. So this is the x-axis, this is the y-axis, and the points are found out, and the line is drawn from the first point to the end point. So let us see the C implementation of the algorithm. We include device.h, which is the header file to include the device to display the line, and then we have the function, define function, which is the round off function, which calculates integer of a plus 0.5. So this function will calculate the round off value. For example, the value is 3.3, it will convert into 4. If the value is 3.5 also, it will convert into 4. So whatever the value may be, it will be added with the 0.5 to get the round off to the nearest integer. The algorithm begins like this. Void line DDA is the algorithm name. Int xa, xy, int xa, ya, xb, yb are the parameters that is passed from the starting point x comma 1, x1 comma y1 and ending point x2 comma y2. And then we are calculating the difference of dx, xb minus xa and dys, yb minus ya. The difference between the x value and the y value is given. And the steps we are going to use in the algorithm, and the k is also the variable used in the for loop. So the algorithm goes like, the steps goes like this. Then we are having the float variable, which is x increment and y increment. So initially we assume x as the starting point xa and y as the starting point ya. So we are going to start with xa comma ya, and then we move. How to move? For this we are using the if condition. If the absolute of dx is greater than dy, means the difference of x is higher, means we are going by the steps of x. Otherwise, we go by the steps of y. That means whichever is higher, we are going by its steps. If dx is higher, we go by the steps is equal to dx. That means difference to step into next point in the line is difference in x. Otherwise, difference in y. So why we need the differences? Because we have to move from the first point, and the difference value will give the continuous steps in order to move to the next contiguous locations. And then once you found out the value, we have to divide. X increment is equal to dx by float of steps. So how much is the length of the line? We have to divide by the step size. Then only we can go to the next consecutive point for the x value. Same way for the y value, we are using the dy by float of steps. That means dy is the difference in the whole line segment. We are dividing this line segment by the steps. So we are dividing. So that is the this calculation does. Then once you can calculate, you are going to set the pixel. That means this pixel, this function will turn on the pixel high, which this plots a point on the line. For example, this point first of all. Then after this, we have to go to the next. Once this point is plotted, we have to go to the consecutive points. How to go? So that is by the for loop. For x is equal to k is equal to 0, k less than steps. How many steps you are going to move? Starting from here, how many steps you have found out by dividing this difference by this function, the step value is found out, and then we are going to till to reach the point x2 comma y2. So this is done by the for loop. So the for loop goes like this: x is equal to x plus x increment and y is equal to y plus y increment, and now we got the new values of x and y. So that is again plotted. Set of x is equal to round of x. This is actually round of x and round of y. He has the bracket actually open brace here and here are the open brace. So printing mistake is here. So open brace round of x and round of y, and then we are closing the. So once this set pixel is done, we are pointing to the next point. Then we are going to the next point. So this is continuously done with the help of this for loop we have created here. So this will end as long as the k less than or equal to steps. Once the end of the line is reached, we are reaching the line drawing. We are concluding the line drawing. So that means we have drawn the line properly. So we have to close the process. Now this open brace of for is closed here, and the open brace of the algorithm, the DDA, is closed by here. So that's all. So this is how the DDA algorithm, the DDA analyzer, digital differential analyzer, draw the lines on the display device. Hope it is easy and simple to follow, and thanks for watching.